This is section 10.1, part 3. All right, so let's see. We just finished example 5. It didn't ask us, by the way, for the equations of the asymptotes or the foci, which we should have been able to find, but that's okay. We'll just do what the directions say, and we'll get plenty of practice, I'm sure, before we're done. All right, speaking of that, let's look at example 6, part A. This is a pretty standard formatting of a question. They're going to give you the equation in the ax squared plus bxy plus cy squared, etc. equals 0 form, and ask you, well, they might ask you to identify the type of conic section it is before you get started. And so this is where you'll want to know, as long as there's no xy term, if the coefficients of x squared and y squared are examined, you notice that they have opposite signs. One's positive, one's negative. So this is definitely a hyperbola. Of course, in the directions they tell you that, but just in case, that could be a question, is which conic section is this? You need to be able to do that. So, as we did with the ellipse, I want to get all of the x things together and all of the y things together, and any constant can go to the other side. Then we want to complete the square, for which the coefficient of the squared term must be positive 1. So for the x's, I'm going to factor out the positive 9 and leave a blank space. For Taylor Swift, I thought I wasn't going to remember to say that. Yeah, leave a blank space, baby, and I'll write your name. You remember that song? Anyway, then the common factor for y squared that I'm going to factor out, because the coefficient of y squared must be positive 1, I'm going to factor the negative 1 out. I'm not going to write the 1, but it's a negative 1 assumed with that minus in front of the parentheses. So this will become y squared plus 6y. This is one of the biggest mistakes that students make, is they forget to change that sign. Once the negative 6y goes into the parentheses, you have to change its sign because the parentheses are behind a subtraction. Okay, so now complete the square for x. Half of negative 4 is negative 2. The square of negative 2 is 4, so I'm adding 4 inside the parentheses. In reality, I added 9 times 4 to the left side, so I'm going to add 9 times 4 to the right side. Then complete the square for y. Half of 6 is 3. 3 squared is 9. I add 9 inside the parentheses, but in reality I'm subtracting 9 from both sides. Okay, so completing the square leads me to be able to factor this to be 9 times the quantity x minus 2 squared minus quantity y plus 3 quantity squared. And the arithmetic here, let's see, is 36, 18, is 9. It's equal to 9. Okay, so then it needs to be in the form fraction minus fraction equals 1. So to make that happen, I'm going to divide both sides by 9. This is one of those rare instances where I'm actually going to ask you to leave that 1 that's left when you cancel underneath so that you can see the x radius. So that division by 1, normally I'd want you to just write x minus 2 quantity squared, stop. But here I want the division by a number, which happens to be 1 this time. So I can see the distance, the x radius that I'm going to be moving in a bit. Okay, and then dividing this by 9 equals 9 divided by 9 is 1. So the center of this hyperbola, which is now in standard form, is at 2, negative 3. The x radius is the square root of 1, which is 1. The y radius is the square root of 9, which is 3. we're supposed to find all of the information. So I found the center. I'm going to go ahead and find the asymptotes because I have everything I need to know to get the asymptotes. It's one of the things that's in that list. So this is going to be y minus the y coordinate of the center, so y plus 3, equals plus or minus r sub y over r sub x. It's always change in y over change in x. 3 over 1 reduces to 3, times x minus the x coordinate of the center, which is 2. All right, now to get the rest, this is where I tend to graph first and find the information requested secondary to that. So let me move to 2. And we're going to be going to -3. And then at least 3 more because of a y radius. Okay, I think I'm ready. Kind of talking to myself a bit there. So the center is at 2, -3. I'm going to move in the x direction 1 unit, so 1 to the right and 1 to the left. I'm going to move in the y direction 3, so up from the center 1, 2, 3, and down 1, 2, 3. So I'm going to draw the box. And then once I've drawn the box, probably better if you used a straight edge than the free-form looking thing I'm doing. It's just not perfect. But the diagonals of the box are important to draw. And then looking at the variable in the positive fraction, which is x, that means I'm going to open to the right and to the left. So go from those dots of the 4 that we drew, the 2 that are in the x direction. And again, it's in the x direction because x is in the positive fraction. Okay, so let's read back through our list to make sure we did everything. Center, yes. Foci, oops, nope, we didn't do the foci. So remember that the focal length c squared for the ellipse is a squared plus b squared. Actually, if you reversed these, because a is always in the positive fraction, b is always in the negative fraction for hyperbolas. If you reversed them and did 9 plus 1, you're still going to get 10. Whether you say 1 plus 9 or 9 plus 1, it's no big deal. But technically, it's the positive fraction denominator plus the negative fractions denominator. And so that's square root of 10. To get to the foci, we're going to start at the center, which is at 2, -3. And because we're going left and right to get to the vertices from the center, that means we're going to go left and right to get to the foci. So from the center 2, we're going to go plus or minus 10 to go right square root of 10. Did I say 10? It's square root of 10. And minus square root of 10 to go left square root of 10. And the y coordinate will stay the same. Okay, and let's see. Vertices. No, I never wrote those down. I plotted them, but I didn't write down their coordinates. Well, those are those red dots. So all we have to do is look at that and see what the coordinates are. Looks like the coordinates would be 3, -3 for the one on the right, and 1, -3 the one on the left. Okay, vertices, equations of the asymptotes, yep. And sketch the graph, yep, all done. Very good. Okay, let's do example 6b. Find an equation of, in standard form, for the hyperbola with vertices 0, 4, and 0, negative 4. If you need to, draw a picture, because this one doesn't say we have to graph it, so any picture I draw here is just for my own peace of mind that I know what I'm doing it correctly. So they told me the vertices are 0, 4, and 0, negative 4, which implies that the center is where? Right, at 0, 0, the midpoint between those two. Okay, so the center is right here. Okay, so that also tells me that the r sub y, the distance I'm moving from the center to the point in the y direction, is 4. And because the vertex is up and down, that means that the positive fraction must have y in it. So far what I can get from this is it'll be y minus the y coordinate of the center, 0, squared, over r sub y squared, 4 squared is 16, minus x minus the x coordinate of the center, 0, squared, over the x radius squared, which I don't know what that is, equals 1. So I've got to have a little bit more information to complete this problem. So let's see what else they say. The asymptotes have the equation y equals plus or minus 2x. Of course, that doesn't concern me much, except for y minus 0, the y coordinate of the center is 0, will give me y, and x minus 0, the x coordinate of the center, will give me x. So that part doesn't bother me. It's just plain y and just plain x. But this number is r sub y over r sub x. And that being equal to 2, well, if we knew either r sub y or r sub x, we could find the other one. Well, I think they did give us r sub y, or we did. We figured it out. Remember, r sub y we calculated to be 4. So could we solve for r sub x? Yeah, it's 2. So that means under the x I'm going to put 2 squared, which is 4. And so my final equation would be y squared over 16 minus x squared over 4 equals 1. Okay. The eccentricity for a hyperbola has the exact same equation as for the ellipse. The eccentricity is c over a. So what that tells us is how broad or how focused those pictures will be. What I mean by that is if I had, I'm going to do a pretty simple looking one, ones that were way spread out, like if it were a crocodile, its jaws would be wide open, like this. Okay, if those were what the things looked like, and the focus would be like here and here. A, the distance from the center to the vertex, would be kind of small, and C would be kind of big. And so C over A, since C is bigger than A, will always be, for a hyperbola, by the way, greater than 1. That has to be true. The other possibility is if the hyperbola is really elongated looking, like this. Kind of like its mouth is almost closed. And of course, C would be that distance, and A would be that distance. And notice how they're almost the same. They're almost the same. So if we think of what's happening here, since the eccentricity is greater than 1, if it's really close to 1, if C over A is small, close to 1, that's when C and A are almost the same. That's this situation here. So these are very pointed, almost like the mouth of the crocodiles are almost closed. Whereas here, C over A is a pretty big fraction. C is a lot bigger than A. And so if the eccentricity is big, it's like the crocodile's mouth is wide open. But if the eccentricity is pretty close to 1, small in other words, you'll have one that's more closed-mouthed, if you will. Okay, so that ends this section. I will see you in class.